Hello guys, welcome back. Today we are going to discuss about directory implementation and free space management. Let's start with the introduction first. Directories are the essential tools for organizing and managing the files in the computer. They provide a hierarchical structure which enables the user to easily locate and access the file from the computer. Directories have many implementations and benefits that user would be aware of maximizing their productivity and efficiency. In the directories, we have the two methods, that is the linear lists and the hash tables. Let us see the linear list. The linear list is the simplest method of implementing the directories, which uses the title names, pointers, and the data blocks. It has some drawbacks. Let us see one by one. In that, first one is the time consuming. The linear list is very much time consuming. The linear list can be time consuming. Essentially, in the presentation directory contains a large number of files or subfiles. It requires to going to through each file sequentially. In the linear list, it was going to check each and every file in orderly, then it goes to execute the key file. It was very much time consuming, when which can lead to delay in finding the specific file needed for the presentation. Now let us see the inefficient for larger directories. As the number of files in the presentation directory increases, the time taken to find a particular file using the linear search grows linearly. As in the presentation, the file presentation directory increases. It takes more time for a particular file in the linear search. It is also increases. This can become impractical for directories with thousands or thousands of files. No sorting benefits. The linear list has no sorting benefits. The linear list does not take advantage in any of the sorting that may be present in the directory. If the files are not arranged in the meaningful order, finding a specific file may become even more cumbersome. Limiting filtering. Linear list lack filtering capabilities. In the linear list, there is no filtering capabilities. If you want to search for file based on the specific criteria such as the file type or creation data, linear list cannot efficiently perform this task. In the linear list, we have limiting filtering. There is no file filtering at all. It was poor in filtering capability. It cannot be efficiently perform this task. Human error. Manual linear search heavily relies on the human efforts and attention. It can lead to errors like overlooking a file or misidentifying a file content. Not scalable. As the presentation directory is size and complexity, linear search becomes less scalable and more prone. The presentation directories is increases and it becomes less scalable and more prone. Now let us see the concept of hash tables. Hash tables is a popular data structure for implementing the directories. They are offer constant time access and insertion, but requires a careful management of the hash collisions. Every collisions resolution strategies will be discussed. Various collision strategies may be discussed. In the hash table, we have the very important technique called as the hashing. It is a method of sorting and retrieving the data at a constant time. It uses mainly three keywords, that is a search key. It must be a search key and a hash table and a hash function. The hash function has various methods. In that, the kmod method, kmod n method, and the mid square method and folding methods are used in the hash functions. In the hash table, we have the four types, that is bit vector, linked list, and grouping and counting. In the bit vector, each block is represented by one bit. If the bit is represented by 1, then the block is free. If the bit is represented by 0, then the block is allocated. In the linked list, there is no wastage of space is going to take place. So the linked list are used in the hash tables. Now let us see the grouping. In the grouping, it stores the address of n-1 free blocks. Address of the large number of blocks can be found in quickly. Now let us see the counting. In addition to the next free block pointer, keep a pointer saying how many blocks are continuously free after the one block. We have to keep one pointer which says how many blocks are free after one block is allocated. It was takes place by the counting method. Now let us see the introduction about free space management techniques. Free space management techniques are crucial for efficient memory usage in the operating system. These techniques measure the memory is used optimally, prevent the memory fragmentation in the presentation. We will discuss here the effective techniques used in the free space managing and in the operating system. Now let us see the contiguous technique allocation. Contiguous allocation is a free space management technique where file occupies the continuous blocks of the memory, where the file is occupied by the continuous blocks of the memory. In between there is no block is empty. This technique is simple and efficient but can lead to the fragmentation. This is the disadvantage of this technique. It leads to the fragmentation over time. It is commonly used in the operating system that do not require fragment files and creation and deletion. Now let us see the linked allocation. Here we use the linked list. Linked allocation is it is also a free space management technique where each file is represented by the linked list of the memory block. This technique is flexible and can accommodate the files in the varying sizes but can lead to the inefficient memory using due to the fragmentation. It is commonly used in the operating system that requires the frequent file creation and deletion. Now let us see the index allocation. Index allocation, it is also a free space management technique where each file has index blocks that contains the memory blocks which make up the file. To make up the files, the pointer is connected to the memory block and it must be has the index block to make up the file. In this technique we have the efficient and allow for the quick access of the files. In this technique it allows quick access of the files but can lead to the wastage of space due to the index block. It is commonly used in the operating systems that requires the frequent file access. It is used for frequent access of the file in the operating system. Now let us see the buddy system. Buddy system is also a free space management technique where memory is divided into the blocks of equal sizes in the power of 2. The blocks are divided into equal size in the power of 2. When a block is allocated, it splits into the equal sized buddies. When one buddy is free, the other buddy try to merge with that buddy. It is split into the two equal sized buddies. When the buddy is free, its buddy is checked to see if it can be merged. As I said, this technique is efficient and prevents the fragmentation. This is very important. In this technique we can prevent the fragmentation but can lead to the internal fragmentation. The fragmentation can be prevented but it can lead to the internal fragmentation. Now let us see the conclusion part of this presentation. Efficient free space management techniques are essential optimal memory usage in the operating system. Contiguous allocation, linked allocation, index allocations and a buddy system are some most effective techniques used today. This choice of technique depends on the specific requirements and the operating system. That's it for today's topic. See you guys in the next video. Until then, take care.